In this video, I will show you how to graph a logarithmic function like these, and along the way we will identify the domain and range and the asymptote. The first thing to know about graphing a logarithmic function is the easiest thing to do is to start with the y values and then find the x values. So it's the opposite of what we normally do. So on a graph this size, I'm just going to do 5 values. So I will do -2, -1, 0, 1, and 2 for my y values. Now, what I recommend doing is start by graphing just the parent function. So when I talk about the parent function, I'm just talking about this part of the function, log base 1/3 of x. I will do the horizontal translation and the vertical translation on the graph itself. So especially if we're supposed to do this without using a calculator at all, this will be the easiest way. Okay, so the next thing you need to understand is looking at this version, looking at the parent function, in order to get the x values, we need to rewrite this in exponent form. So the way you do that is you start with the base, which is 1/3, and then the x and the y are going to switch places. So the x is going to wind up on the left side of the equation, and the y is going to wind up as the exponent. So this is the exponent form of the parent function. And this will be helpful because I can use this to find all my x values. So notice that the x values are going to be 1/3 to the y power. So that means 1/3 to the -2 power, 1/3 to the -1 power, 1/3 to the 0 power, 1/3 to the 1 power, and 1/3 squared. I accidentally put it 2. So got to fix that real quick and go with 1/3 to the 2nd power. I recommend starting from the bottom and then working your way up. So 1/3 squared would be 1/9. 1/3 to the 1 power is just 1/3. Anything to the 0 power is 1. Now a shortcut for these is that they will just be the reciprocals of the bottom ones. So this will just be 3, and this will be 9. Okay, so these are the 5 values that I will graph for my parent function. Okay, so let's go ahead and graph them. Keep in mind that the parent function for a logarithm will always have the y-axis as the asymptote. So 9, -2 is going to be right here. 3, -1 is right here. 1, 0 is right here. 1/3, 1 is about here. And 1/9, 2. Well, 1/9 is so close to 0 that it's going to appear to touch, but we know that it doesn't. So now let's do not connect the dots. All right, we can see what the parent function is doing. But the real function has the following transformations. The +2 on the inside is actually to the left by 2. And this -2 on the end means the graph will be shifted down 2. So I'm going to move each of these 5 points left 2 and down 2. Okay, so left 2 and down 2 will be like here. All right, left 2 and down 2, this will be about here. Okay, the next one will be here, and the next one will be here. And the next one, let's see, again, left 2 and down 2 will be here. So here are the same 5 points. The y-axis was the asymptote. All right, logarithmic functions have vertical asymptotes. Because of the left 2, the vertical asymptote will have shifted to the left 2. So my new vertical asymptote will be here at x equals -2. Okay? When it's not the y-axis, make sure you draw a dotted line. Okay, so did they give me a place to write down that stuff? All right, I'll just do that at the end. So the graph. We'll just go ahead and draw the graph now. All right, so your graph should look something like that. Okay, so they wanted the domain, the range, and the asymptote. Okay, so the domain. The domain is how far it goes from left to right. So that's going to be -2 to infinity, with parentheses on the -2 to show that it never actually reaches the asymptote. The range is going to be from -infinity to +infinity. Because the range is the y values, how far it goes from bottom to top. It goes down forever and it goes up forever. So there's the range. The new asymptote is the vertical line x equals -2, which we already discussed. So that's it for problem number 1. Let's do the same thing for problem number 2. Again, for logarithmic functions, I like to start with the y values, and I will do -2, -1, 0, 1, and 2 are good to use. So I need the x values. To find the x values, oh yeah, keep in mind, right now I'm only graphing the parent function. I'm ignoring the +2 and the -4. So I need to rewrite the parent function in exponential form. The base is 6, so I'm going to start with that. So I put down my 6. The x and the y switch sides. So the x is going to be over here, and the y will come over here as the exponent. So this is exponent form, and that's what I will use to find my x values. So I'm talking about 6 to the -2 power, all right, because I'm doing 6 to the y power. So 6 to the -2 power, 6 to the -1 power, 6 to the 0 power, 6 to the 1 power, and 6 to the 2nd power. Starting from the bottom, 6 squared is 36. 6 to the 1 power is 6. Anything to the 0 power is 1. And then the reciprocals. So this will be 1/6 and 1/36. Okay. Let's graph these points, but remember, we will not connect these dots. This is not the final answer. So 1/36 comma -2. 1/36 is so close to 0 that it will appear to be on the line. So 1/36 comma -2 is almost like 0 comma -2. 1/6 comma -1 is not much better. All right, it still will appear to be on the line because it's so small. Now, then we have 1 comma 0, and then we have 6 comma 1. All right, obviously 36 comma 2 will be far off the graph. So these 4 points will have to be sufficient. Do not draw the curve because this is just the parent function, though you get the idea. For the final answer, we need to consider these 2 transformations. The +2 on the inside means the graph will be shifted to the left 2. The -4 on the end means that the graph will be shifted down 4. So left 2, down 4. That's what I will do to these 4 points. Okay, so left 2, down 4. It's going to be like here. And the next one will be here. And the next one will be here. Okay, so left 2, down 4. All right, so these 4 points will be here now. Pay special attention to what's happening to the vertical asymptote. Because of the left 2, the vertical asymptote shifted to the left 2. So make a dotted line to show the new vertical asymptote. All right, there's my new vertical asymptote. Okay, so now we can go ahead and draw the curve. Okay, so your graph should look something like that. All right, with that in mind, let's go ahead and write the domain and range and the asymptote. So the domain, the x values left to right, that's going to be -2 to infinity. The range, that's the y values, so bottom to top, that is -infinity to positive infinity. And the asymptote. All right, that's going to be x equals -2. So that's it for problem number 2. Problem number 3. Again, I like to start with the y values whenever I'm graphing a logarithmic function. And let's use -2, -1, 0, 1, and 2. Now, I'm going to start by graphing only the parent function, which is this, log base 3 of x. I will do the transformations of right 2 and down 3 on the graph itself. So, I need to find the x values. For that, I need to rewrite the parent function in exponential form. The base is 3, so I'll start there. The x and the y are going to switch sides. So the x will come over here and the y will come over here as the power. So this version of the parent function will give me the x values. All right, x is equal to 3 to the y power. So that means 3 to the -2 power. 3 to the -1 power, 3 to the 0 power, 3 to the 1 power, and 3 to the 2nd power. Start from the bottom and work your way up. 3 squared is 9, 3 to the 1 power is 3, anything to the 0 power is 1. And then the top 2 are just the reciprocals of the bottom 2. So this will be 1/3, and this will be 1/9. So these are the ordered pairs of the parent function. Let's go ahead and graph them. 1/9, comma, -2 is basically going to appear to be on the line because it's so small. 1/3, comma, -1 will be about here. 1, comma, 0. 3, comma, 1. And 9, comma, 2. Do not connect these dots because this is not the final answer. So, because of the -2, I know the graph is moving right 2. Because of the -3, the graph will move down 3. So I'm going to move everything right 2 and down 3. So right 2 and down 3. Okay, the next one will be about here, and then here, and then here. Okay, right 2 and down 3 will be about here. Okay, pay special attention to the asymptote. Because of the right 2, the new vertical asymptote will be at x equals 2. So go ahead and put yourself a dotted line at 2. All right, that's the asymptote. So the actual graph, the final answer, is going to look like this. Okay, so let's talk about the domain and the range and the asymptote. All right, so the domain, that's the x values. Left to right, the graph goes from, well, not negative anything, the graph goes from 2 to infinity. The range, okay, that's the y values from bottom to top. This graph goes down forever and it goes up forever. So that's negative infinity to positive infinity. Now the asymptote, we have this vertical asymptote at x equals 2. So that's number 3. All right, let's do one more on this video. Natural log. All right, this should be interesting. We're still going to start with the y values whenever we do logarithms. So I'm going to do -2, -1, 0, 1, and 2. Now they told us not to use a calculator, and I don't think we're going to be able to do this without a calculator. So we might have to cheat a little bit because of the natural log situation. So be emotionally prepared for that. So in order to find the x values, first of all, understand that I'm only talking about the parent function, y equals natural log x. So what I need to do is rewrite this parent function in exponential form. Now, natural log is log base e. So if I rewrite this in the other form, I'm going to start with that base e. Okay, and then the x and the y are going to switch sides. So I'm going to have x equals, and then it will be e to the y power. So this is what I'm using to find all these x values. Okay, so I'm doing e to the -2 power, e to the -1 power, e to the 0 power, e to the 1 power, and e squared. Okay, and so that's the thing. E is approximately 2.72. So, you know, I know that anything to the 0 power is 1, so I can definitely do that. So e to the 1 power, all right, e is approximately 2.72. I'll call it 2.7. So this will be 2.7. All right, for the rest of these, I'm going to at least need a 4-function calculator. So I'm just going to grab my 4-function calculator. I'm going to use the approximation of e is approximately equal to 2.7 for these purposes. So e squared, I'm just doing 2.7 times 2.7. So that's 7.3. Okay, 7.3. All right, now the top two will be the reciprocals of the bottom two. So that means 1 over 2.7. So 1 divided by 2.7, that's 0.4. And 1 divided by 7.3. So 1 divided by 7.3, that's 0.1. Okay, so this is an approximation of the parent function, y equals natural log of x. So let's plot these points and see what we have so far. So 0.1 comma negative 2 would be about here. 0.4 comma negative 1 would be about here. 1 comma 0, 2.7 comma 1 is about here. And then 7.3 comma 2 is about here. Okay. Do not connect these dots because that is not the final answer. For the final answer, we need to move all of these points left 6, okay, because of this, and up 3 because of this. So left 6 and up 3. So let's see. All right, so that's going to be here. Then the next one is about here. And the next one is here. All right, the next one is about here. Okay, and the last one, let's see, 1, 2, 3, 4, 5, 6. 1, 2, 3. So it's about here. Okay, the vertical asymptote, because of the left 6 shift, my vertical asymptote will be over here at x equals negative 6. So this is my vertical asymptote. Go ahead and draw a dotted line at x equals negative 6. So there's my vertical asymptote. And then go draw your graph using these 5 points. And that will be a pretty decent approximation. Okay, so your graph should look something like this for number 4. Okay, let's go ahead and do the domain and range and asymptote. So the domain from left to right is negative 6 to infinity. The range is the y values, so from bottom to top, that is negative infinity to positive infinity, and the asymptote. As we mentioned earlier, is going to be x equals negative 6. All right, that one was a little tricky because of the natural log being base e. So we had to cheat and use at least a 4-function calculator. All right, guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.